Friends, today I'm going to solve LeetCode problem number 1870, minimum speed to arrive on time. So here we are given a floating point number hour, which represents the amount of time you have to reach office. Okay, so which means that we are going to office, and to commute to office you must take n trains in sequential order, and n is the length of this array. So this array actually is an integer array of length n, where each of the element describes the length of the ith train. So basically this array has multiple number of trains and each train has some distance, which is an integer value. Okay, and now each train can only depart at integer hour. So we are given this hour and we are given integer array, and in this integer array now we need to take each of those trains in sequential order, and we can only depart from each train in integer hour. So for example, if we are taking train 1 and it takes time 0.75 hours to reach its destination, then the next train we can only take it at the next integer hour, which is equals to 1. So the remaining time 0.25 hour is like just we stay there and wait or do something. So basically it's only integer hour that it departs at. Okay, and now here we need to return the minimum positive speed that all the train must travel for you to reach the office on time, or -1 if it is impossible to travel on time. Okay, so we need to find the minimum positive integer speed. Okay, so basically we are given the distance, we are given the hour, now we need to find the speed, and speed should be minimum positive integer. Let's take this example and basically look at this problem once again using this example. So what are we given here is, let's first take care of this, like return -1 it's if it's impossible to be on time. So in what case is it impossible to be on time? So let's suppose instead of hour 6 we are given an hour 1.2. Okay, so now we are given 3 different trains. So which means that one train, once we travel the first train, we can depart at 0th hour, and then let's suppose that we are traveling with the maximum speed. So even though we reach here at 0.01 hour, we are still going to wait until it's hour 1, right, before the next train departs. So the next train will depart at hour 1, and even though it's traveling in maximum speed, we are still going to wait until the next hour, which is hour 2, for us to catch the next train, right, and depart. So the next train, which is traveling 2 kilometers, will depart at time 2, hour 2. So the next time, the maximum time that we would require is 2 point some value. This could be very minimum value, it could be 0.1 or less than that. So even though it's 2.0 some value, it's still larger than 2, right? So that means that we cannot reach our destination in 1.2 hours or in any time which is less than or equal to 2, because we'll need a value which is 2 point some value, right? So it should be greater than 2. So that is what would mean that we are impossible to reach. So in that case we are going to return -1. Okay, so now that we have checked for this case, now we need to check if it's possible, then we need to find our minimum positive integer. Now how are we going to find our minimum positive integer? Okay, so let's first look at this. The tests are generated such that the answer will not exceed answer, which means the speed will not exceed 10 to the power 7, and hour will have at most 2 digits after the decimal point. Okay, so hour will only have at most 2 digits after the decimal point, and the maximum speed is 10 to the power 7, and of course the minimum speed should be 1, because at a speed of 0 we won't be able to travel at all. So the minimum speed should be 1. Okay, so now we know that. So let's see, if we are traveling these distances, like from distance from train 1 to 1 3 and 2. So now let's just think, if you want to travel and you want to reach the destination, you could just travel at the maximum speed and then reach the destination at the maximum speed, right? So let's suppose we have distance d1 for 1, d2 for this value next, and d3 for the last one. Okay, and if you're traveling at speed s, okay, so let's suppose that all of the train is traveling at the same speed. So now if all the train are traveling at same speed, then we can divide by as to get our time, right? Because we know speed is equals to distance by time. So if we just reverse, if we just take this over here and put this over here, then we'll have time equals to distance by speed. So based on this formula, we are able to get the time we need to travel the first train. Okay, similarly we are going to get the time we need to travel the second train and third train. Now if we are traveling at the maximum possible speed, which means that the speed is very high, then the time will be very less, right? So we are able to reach within the given hour, okay, if we are going to travel in the maximum possible speed. But what if we are traveling the least speed, the very minimum speed, then it could be, there could be a chance that we are not able to reach within this hour, right? Let's suppose we are traveling at a speed of okay, let's take another example here, a good one. Yeah, the earlier one, 2.7. Okay, so now if we are traveling, if we want to reach within 2.7 hours, so let's suppose we are traveling at the speed of 1. So if we are traveling at speed of 1, then our time here would be 1 by 1, which is equals to 1, right? And for this, 3 by 1 will be equals to 3. So our speed is equals to 1, so the time is equals to 3, and here we have 2. So if we are traveling at this distance at this speed, which is equals to 1, we are able to reach in 1 3 and 2, which is equals to 6 hours. Okay, so if it was 6, then that would be the perfect speed, right? That would be the speed that we would be traveling in. So this would be minimum one. Now let's just look at this example only. Okay, if you're traveling at 6, now what if I increase the speed by 2? If I increase the speed by 2, then dividing by 2, I would definitely get a value less than 2. So I will be traveling in less time. So the overall time will be less than 6. So the hour given to us is 6, and at certain speed s, which is the result, I am able to travel within 6 hours. In any other speed which is greater than s, let's suppose this is a speed axis, that if we are traveling at a speed higher than our time, let's suppose this is a time axis, then our time will actually reduce. So we are actually traveling in less time. But if we decrease our speed, so if we are going towards this axis, towards the left, then what happens is our speed is decreasing. As our speed decreases, we will take more time, right? So more time means now we are taking more time, so this way. So here you could see that now here is an intersection point, at which point we have the hour that we need. So at this hour we need to take this many hours to travel. So basically we have this point where we can travel at the speed as, so that we are able to reach at time 6. And if we take any speed less, then the time increases. If we take any speed greater, than the time decreases, right? So basically this is splitting. Basically we are splitting, and we have some kind of sequence here, some kind of order, right? So in this case we are able to use binary search. So this is how we can know that we can use binary search in this problem. So we are basically going to use binary search to solve this problem. So now let's see how are we actually going to do that. So what we do is we have the distances. Okay, let me just clear this thing out. So we have the distances and we have our hour. Now we need to travel within this hour. And what are we given here is the maximum speed could be 10 to the power 7. Now we are performing binary search. So for binary search, what do we need? We need the left and the right, so that we can find the middle value. So our left pointer, let's suppose this is left, will be equals to 1, because that's the minimum speed, because speed should be an integer value. It should be a positive integer. It means it is an integer value. So the minimum speed should be 1. The speed could have been 0 point some value if it were not to be an integer value, but since it's integer, we are going to take a value 1. And the maximum would be 10 to the power 7. Okay, so this is the maximum speed, and now we take the mid value of the speed. So based on the mid speed value, what we do is, based on our previous formula, we will find the time taken. So d1 plus d2 divided by the speed plus d3 divided by speed, and so on. And here there could be some gap values as well. If this is not an integer, then we need to make it an integer, right? So basically we are going to do all of those things, and based on these time, the overall time that we calculate for this speed, we are now going to compare with the hour that we have to reach. So if we are taking less time, which means that we are traveling at a speed higher, and if we reduce the speed, we might be able to reach within the same hour. So if we're taking less time, then we reduce our speed. So basically if this is left, okay, and this is right, so we now shift our right, and our right is now equals to the mid value. And now if in case our mid value is some value here, and now in this case, if our mid value, with this mid value, our time is greater than the hour that we have, that would mean that we are taking a lot of time, so our speed is less. So we should increase our speed now. So to increase the speed, what we need to do is, we are now going to shift the left value. So our left value will be equals to mid plus 1. So we are going to perform this step until and unless we find the speed where the time taken is equals to the hour that we have, and based on that we are going to return the value. So now let's look at this problem and start coding. So first of all, we need to take care of this -1 possibility. So -1 will be when, let us first define n, which is equals to distance of length. Now if n is equals to if n is greater than math dot ceiling of hour, that is when we return a -1. Okay, now let us define our left is equals to 1, and the right, which is the maximum is speed, which is equals to 10 e7, and then mid value, which is equals to, let's just write that as -1. Now we need to perform binary search. So while left is less than right, so we are going to find the mid, which is equals to math dot floor. So this will give us only the integer value of speed. So floor of left plus right divide by 2. Okay, now using this speed we need to calculate the time, right? The total time, right? So we are just going to create a new function that would calculate the time. Okay, so let find time equals to function, and here we are going to pass the speed that we found, which is equals to this value m. So let time equals to 0. Okay, so initially it is equals to 0. Now we have to find the time for each of the values in our array, right? So starting from the first, less than n I plus plus. Now here what we do is time. Okay, so if the earlier time that we reached the station was not an integer, that is if time is greater than math.floor value of time, so floor value, like let's suppose if I reached a station at 2.7 hour. Okay, now I am taking a floor value which is equals to 2. So since this is greater than 2, that would mean that I can only depart at the next hour, which is 3. If this was an integer value, then I would have just departed at that hour. So if this is not a integer value, not an integer, then at that case we need to make time an integer. So time equals to math.ceiling value of time. Okay, or we could have just done that math.floor of time plus 1. So this is our time, and then next we are going to add the time we need to travel the next train. So time is equals to distance, right? So distance at index I divide by the speed. Okay, so this is the time we took, and this is to convert it into integer. Okay, so now this will return integer time. So here now we need to compare our time, right? We are comparing the time that we received with the hour that we have. Okay, so if find time with the speed is, okay, so what did we do here? So if the time we found was greater, that meant that speed is less, so we need to increase the speed. So at that point left is equals to mid plus 1. So if time is greater than hour, then left is equals to mid plus 1, right? Else if time is less than or equal, then we could travel it in much like less speed. So right equals to mid. Okay, once we have done, finally we are going to return our left value. Okay, so yeah, this would be outside here. Okay, so this is all about our code, and this value will be the resulting speed. Let's run our code and see if it works. Awesome, it passed all the test cases. Now let's try to submit this. Great, so we are able to pass all the test cases here. So let's look at the time complexity and the space complexity. So we know that we are using binary search, so the time complexity of binary search is O of log n. And here, since we have the value of r, which is a constant value, we can take this as a constant because like it is not changing at all, so that would be a constant value. And then here we are also finding time, right? And finding time, we are performing an iteration for each of the array, right? So that would be O of n time complexity. So the worst case time complexity is O of n, and the space complexity here is constant because we are not using any space which would increase linearly, for example array or list. So yeah, that is all about this problem. Let me know in the comments down below what do you think about my solution. Thank you.